All right, in this lesson, we're going to take a look at a few more equations and methods by which to solve them so that when you see them in the class exercises, they won't be as a surprise, okay? Here again, we have this, a second power equation, so we suspect we're going to have to do some factoring. It's not set equal to 0, so that's going to prevent us from solving it right away. So we can distribute this over here, of course. That'd be a negative 6x minus 8. And this comes down. And now it looks like we have some terms we can join up. And we got 3x squared. Looks like we have a minus 4x, but if we pull that negative 6x over, it'll become positive 6x. And of course, we should pull over the 8 because we want this thing set equal to 0, and we can factor it. All right, so we got 3x squared plus 2x plus 8 equaling 0. And now that's ready to factor. And I'm going to leave that for you to factor that and solve the solutions because it's really no different than what we did in the previous exercises. Now, here's another one. Common mistake. Oh, it's two things multiplied, therefore we just set it to what's equal over here. No, no, no. This is not 0, okay? It can only be set equal to the opposite side when the opposite side is 0. Can't do anything there except distribute. 3x squared minus 23x. Sorry for that. And let's bring the 8 over. So now we will have it equaling 0. Okay. Now it looks like we can factor. Let's go and factor this guy. Okay, we know it's going to equal 0. 3 is prime, so that can only break up as 3x and 1x. And of course 8. Well, so we've got a minus 8, which means we've got to have a plus and a minus over here. 8 threes are 24, less 1. Yeah, that's probably the combination. I'm going to go with minus 8 here, plus 1. Now, again, our check. 24x negative plus 1x, plus 1x, that gives us the negative 23. We're in good shape. So we conclude 3x plus 1 equals 0, which just means 3x equals negative 1, and x equals negative 1/3. And x equals 8. There are our two solutions on that guy. Okay, now here, you're going to say, wow, I don't like this because it's a 4th power. And this here is the 2nd power. So could I expect up to 4 solutions? You might. We'll see what happens. Now, problems like this, my suggestion is you make it look more user-friendly. You say, gee, you know, if it was a t squared there, I could factor that. So, well, it's not t. We're going to do what we call a substitution. We're going to let the t squared term be u, okay? So that now over here, this reads minus u minus 4 equals 0. Well, if u is equal to t squared, and if I square u, then that must mean I have to square t squared, which gives me t to the 4th. So over here, I can't have these mixed variables in that equation. I have the t to the 4th, which I've now identified as u squared. So this can now be 3u squared. And now the equation is ready to factor, but it's going to factor in terms of u. Okay, so let's proceed with that. Factor that in terms of u. All right. 3 being prime, 3u and u. Okay, and then we got to play with the factors of 4 and somehow come up with a negative 1. Well, 4 over here would give me a 12 on my loop, which would be entirely too big. So it's not likely to be that combination. 4 here and a 1 here might work. That seems to work. Then let me clean that up again. Sorry for that. Okay. And now our signs. So the signs, okay. Remember, I got a minus, so I got a plus and a minus combination here. All right. So I'm trying to get after it's all said and done, a -1. So let's try this. Plus here, a minus here. Of course, that gives me -4u. And this gives me +3u, which gives me my -1u I'm after. So here, obviously, we can see that u is going to equal 4/3. Okay? And over here, u is going to equal -1. Now, I don't want to know what the value of u is. I'm after t. So then I bring back this substitution. T squared is equal to 4/3. And t squared is equal to -1. Now, if t squared is equal to 4/3, then t must equal the square root of 4/3, which we should remember is both positive and negative. In this case, however, if we say, oh, we take the square root, then that would say t is equal to the square root of -1, and we know that that's imaginary. So what we say is this contributes an empty set in terms of solutions. Okay? So that's our problem there, solved by method of substitution, which you're going to find very convenient at times for a number of different problems. Let's go over to this one. X to the 6. Again, these higher power expressions are subject to have multiple solutions. And the fundamental theorem of algebra will tell you that the fourth power equation will have up to 4 real solutions. Well, it actually has 4 solutions, but only 2 of them are real. And that's what we're concerned about by and large. So I might expect 6 solutions here. Let's see what happens. I'm going to start by pulling everything over. X squared minus 10x to the 4th, because it's left that one side, come over to the left side, plus 9x squared equals 0. Now, if I proceed to factor that, I say that's 9x squared. Okay? If I proceed to factor that, I'm going to say, well, the first thing I should always look for is a common factor. This, I am sorry, is x to the 6th. Okay? And so it does have a common factor, x squared. So let's remove that. X squared is common. Leaves me with x to the 4th minus 10x squared plus 9. Now, if I factor this, and you may want to do the substitution, you might not need to. You might just say, yeah, that breaks down to x squared and x squared, and that's fine. Always know the substitution is available for you. X squared, this is equal to 0. So this looks like it's going to go to what? A -9 and a -1. Now, well, guess what? Each of these factors again, right? So there you go, x squared, x plus 3, difference of squares, remember? X minus 3, x plus 1, and x minus 1. And that's equal to 0. Well, now guess what? And what are our answers? Well, this would be x minus 1 equaling 0, which would say x equals 1. This would give us x equals -1. This would give us x equals 3. This would give us x equals, what? Of course, x equals -3. And this, of course, would give us x equals 0. All right. So here we have 1, 2, 3, 4, 5 solutions. Okay, this is what we'll end up calling a multiplicity. We'll talk about that later. But nonetheless, okay, you can see how the factoring was crucial to solving the equation. Okay, so the thing to learn, factoring, you can review the factoring slideshow I have on Moodle. Okay, the substitution, this will prove very important for the problems we're going to do in class. Okay, and the need to equate the equation to 0, okay, before proceeding with factoring. Okay, that's enough. We will have to pick up with that number 5 at another lesson. Very good. Thank you.